everybody, in this video we're covering walks, paths, cycles, and connected graphs. We'll start with definitions, then we'll do some worked classification problems, and finish up by testing connectivity. Let's start with our core definitions. A walk is a sequence of vertices that are connected by an edge. A path is a walk with no repeated vertices, which means we also don't have any repeated edges. A cycle is a walk that begins and ends at the same vertex. A graph is connected if there's a walk between every pair of vertices, and notice we said a walk, not an edge. A graph is disconnected if at least one pair of vertices has no walk between them. A component is a connected piece of a graph. A connected graph has exactly one component. A disconnected graph will have two or more components or pieces. For example, this graph with vertices A, B, C, D, and E has one component and is connected. Let's compare that to a disconnected graph. This graph has a component containing A, B, and C, then it has a second component with D and E. Because the two components are not connected, we would say this graph is disconnected. Let's practice classifying some sequences of vertices. For each sequence, we'll only give one description. We'll use cycle as the highest, path as the middle, and walk as the least. Let's start with A, B, C, D. Let's trace out the sequence. We can go from A to B, B to C, and then C to D. We would call this sequence a path. Now let's try A, B, F, A. We're going A to B, B to F, and then F back to A. Because we started and ended at the same vertex, we call this a cycle. Next we have A, F, C, F, E. So we'll start A to F, F to C, but notice now we're going back through the same edge when we go from C to F. We finish by going F to E. This time we're going to call this only a walk. Because we repeated vertices and edges, it can't be a path or a cycle. Our last one says A, B, C, D, A. So we're going A to B, B to C, C to D, but we don't have an edge from D to A. In fact, D and A are not adjacent. That says this is none of these. It's not a walk, it's not a path, it's not a cycle because it put in a sequence of edges that's not connected. Let's take a look at a few graphs and decide if they're connected. Our first one has a component with A, B, and C, and then separately has a vertex D. We would say this is not connected. We have a triangle and then a lone vertex, so we have two components, which makes the graph not connected. When we look at G2, it has a series of A, B, C, D. This is connected. What we see is a single path that links all four vertices. When you look at G3, you might first think this is connected because I can see the edges from A to D cross over the edge from B to C. But let's put some color on the graph to really highlight the connections. We can see A is connected to D and D is connected to F. We can also see B is connected to C and C is connected to D. But what I have here are two separate components, which says this graph is not connected. Let's finish up with G4 that has 5 vertices all connected to a central vertex of C. This time the graph is connected. We can see every vertex can be reached through a series of edges. As a quick recap, let's look at our key takeaways. A walk is any sequence of adjacent vertices. Repeats are allowed. A path is a walk, but we can't repeat vertices, which means we have a strict open route. A cycle is a walk that begins and ends at the same vertex. Because a cycle is a walk by definition, we're not going to have any repeated edges or vertices. The only thing you'll see twice is the vertex that it starts and ends with. When we look at connectivity, connected means we have a walk that joins every pair of vertices. Otherwise, we know that our graph is split into multiple components.